Now we're going to do some problems that we're going to call endpoint maximums. Basically, in these problems, you're given a particular length of wire, and you're going to do, or rope, and you have to form a circle and a square, or two shapes. How much of the wire should be used for the square, and how much should be used for the circle to enclose the maximum total area? Okay, so that is going to be our primary equation, is going to be our area. Now suppose the square has sides x, x, and a radius r. Well, then the area is going to be x squared plus pi r squared. And we also know that the total length has to be, let's see, 4x plus, so 2 pi r. Now we're going to solve this for x, so let's look at some bounds on our domain. Clearly, x, what if the square were to take up all of this space, and then you would have 4x is equal to 4 feet. So x has to be positive, so it's very clear x is going to have to be between 4 and 1. All right, well, let's go ahead and put our 4 there, and let's solve this for r. So r is 4 minus 4x divided by 2 pi. And I'm going to rewrite this as 2 minus 2x over pi. And now I'm going to plug my secondary equation into my primary equation. So my area formula becomes x squared plus pi, and it's going to be times this whole thing squared. So this is 2 minus 2x divided by pi. All right, so I'm going to, square this mess out. So my area becomes x squared plus, now this pi is going to get squared, so we're going to wind up with just 1 pi in the denominator. So I'm just going to leave it that way. And when I multiply this out, this is 4 minus 2 times 4, 8x plus 4x squared. Now for simplicity's sake, I'm going to get least common denominator, 1 over pi, and I'm going to collect my x squares. So this is 1 plus, pi plus 4 times x squared. Now that's just a constant. It's an ugly constant, but it's constant. Minus 8x plus 4. So this is my area function. You know what's coming. Let's take the derivative of the area. Okay, and that's going to be 1 over pi times 2 pi plus 4 x minus 8. Now, let's see, when does this equal 0? It equals 0 when the inside equals 0, or when x is equal to 4 over pi plus 4. It's not a very nice number, but we're going to use 0.560. Now, we need to check our critical points and our endpoints. All right, so when x is 0.560, so x is, I like doing my charts, I'm sorry. What is the area? The area is, okay, I'm going to go back to this formula right here. It's ugly, but I can do it. It's 1 over pi times 2 times, not 2, sorry, I knew I was making a mistake, pi plus 4. Do you mind if I start over there? I'm just having trouble with my writing. Don't get distracted by your computer beeping at you. Seriously, turn off your email. Now, x squared, so this is 0.56 squared, minus 8 times 0.56 plus 4 Isn't that lovely? I did all this in my head. Do you believe me? You shouldn't. You really shouldn't, because I'm lying. All right, so my area is 0.56. Now let's look at our endpoints. At x equals 0, I like x equals 0. It's much easier. What is my area? All right, let me go back up to this formula. It's, well, it's pretty straightforward. It's just pretty good. 4 over pi. Did I do that right? 4 over pi. No, that's not right. When x is 0, oh, it is 4 over pi. When x equals 1, oh, by the way, this is about 1.27. When x equals 1, what do I get? The area is 1 over pi times pi plus 4 times 1 minus 8 plus 4. Let's see, that goes away. Oh, so the area is just 1. Now, I want to maximize the total area. And where does that occur? That occurs right here when x is 0. So the maximum area, by checking at it, occurs when the whole thing is enclosed in the circle. Didn't expect that, did you? All right. You give it a go, and when you're done, turn off the video and finish your homework.